Hi viewers, now we discuss the topic exercise 1.4 second question. Prove that root p plus root q is irrational where p comma q are primes. Here root p and root q are clearly irrational number. Summation of irrational number get the result also irrational. But we prove this one solution as in indirect method proof. For that one purpose we apply by using contradiction method. Let us assume here root p plus root q is an irrational, but our assumption we choose here is a rational number. That is root p plus root q equals to we choose a fraction a by b where b is not equals to 0 and a comma b belongs to integer. In LHS part contain each term as square roots are there. Apply squaring on both sides. We get it here as a next step root p plus root q whole square equals to a by b whole square. Clearly it is in the form of a plus b whole square equals to a square plus b square plus 2ab, where a value equals to root p and b value equals to root q. So a square means root p whole square plus b square means root q whole square plus 2ab means 2 into root p into root q equals to a by b whole square can be treated as a square by b square. So square and square root deduct as in next step p plus q plus 2 in root p into root q as in the form of root a into root b that equals to root of a into b. Clearly root of p into q equals to a square by b square. So p plus q we write it as in the term in single bracket the term transpose to RHS. So 2 root of pq equals to a square by b square minus, because that value before plus sign is there, we transpose to RHS, we get it p plus q. So equals to a square by b square minus p plus q can be written as p plus q whole divided by 1. 2 root of p into q equals to take LCM denominators, that is b square into 1. Do cross multiplication, a square of 1 minus keep as usual cross multiplication b square of p plus q. Next step continuation as in next page. 2 into root of pq equals to a square minus b square of p plus q whole divided by b square. So 2 transpose to RHS here. Next step root of pq equals to numerator a square minus b square of p plus q whole divided by denominator 2b square. Since a comma b are the integers and p comma q are the primes, clearly a square minus b square of p plus q is a integer whole divided by 2b square is also a integer. It is in the form of p by q is a rational number. Now observe as in the above equation root of pq is an irrational number. Now in RHS side a square minus b square of p plus q whole divided by 2b square is a rational number. We know that irrational number is not equals to rational number. This is equation 1. From equation 1 we get irrational number equals to rational number. This is contradiction to our assumption. Therefore root p plus root q is an irrational, hence proved. I hope to understand this solution. Thank you for selecting my video.